China just deployed humanoid robots performing tasks engineers predicted would take another decade to develop. While America doubles down on perfection, China is flooding consumer markets with automation that costs less than a used car. Today, I'm counting down 8 technologies in the robot race between China and America, and number 1 will show you which approach actually defines the future of robotics. Subscribe because this changes everything. Kicking off at number 8, the Unitree G1 humanoid robot. Unitree's G1 stands 4.3 feet tall with 23 degrees of freedom, enabling walking, running, and complex kung fu movements. The system weighs 77 pounds, including battery and retails for $16,000. Watch as demonstration footage shows the robot folding itself for storage and executing choreographed dance routines with precise joint coordination. Here's the catch though. While Boston Dynamics Atlas represents decades of breakthrough research, the G1 operates primarily in controlled environments with limited autonomous decision-making. China chose affordability over perfection, smart strategy, or cutting corners. But America's delivery solution takes number 7. Coming in at 7, the Zipline Medical Drone Network. Zipline operates the world's largest drone delivery network, completing over 1 million autonomous flights delivering medical supplies, blood, and vaccines to remote hospitals across 8 countries. The drones fly at speeds up to 80 miles per hour with a 62-mile range, dropping packages via parachute with pinpoint accuracy. Each distribution center serves populations up to 12 million people. What sets Zipline apart is mission-critical reliability. While China's Meituan delivers restaurant orders, Zipline delivers emergency blood supplies. Different priorities, different engineering standards. The system maintains a 99.9% delivery success rate in all weather conditions. But Chinese agricultural automation dominates the middle tier. At number 6, the DJI Agras T100 agricultural drone system. DJI's Agras T100 agricultural drone carries 220-pound payloads of seeds or pesticides, operating autonomously during nighttime hours using thermal and optical sensors. The system covers fields with precision spray patterns, reducing chemical usage compared to traditional methods. China deployed complementary systems, including 108 arm cotton-topping robots processing 64 to 99 acres daily, 120 times faster than manual labor, and GPS-enabled transplanters covering 15 to 17 acres per day. Here's how it works. The drone uses RTK GPS positioning accurate to centimeter-level precision, with intelligent obstacle avoidance allowing operation in complex terrain. Multispectral cameras analyze crop health in real time, adjusting application rates based on plant conditions. Compared to established agricultural technology companies like John Deere, DJI achieved rapid market penetration in Asia through lower pricing and integrated hardware-software systems. However, Western markets face regulatory restrictions on autonomous agricultural drones, particularly regarding nighttime operations and beyond visual line-of-sight flights. While America debates regulations, China automated entire agricultural regions. This demonstrates fundamentally different approaches. America optimizes yield per acre. China eliminates the need for human labor entirely. The autonomous vehicle technology reshaping transportation ranks next. Holding the 5 spot, China's Level 4 autonomous vehicle deployment. China deployed 16,000 autonomous test vehicles across 19 cities with 20,000 miles of designated smart roads in 2024. Vehicles feature NVIDIA Orin chips delivering 508 trillion operations per second computing power, integrated with 11 HD cameras, 12 ultrasonic sensors, and 5 radar systems. The JIYUE-01 enables voice-commanded autonomous pickup from distances up to 1.2 miles using vehicle-to-infrastructure communication. The engineering approach involves dedicated infrastructure with 5G connectivity and roadside computing units that supplement onboard processing. China's regulatory framework permits Level 4 autonomy in geo-fenced areas, while consumer adoption rates reach 85%, significantly higher than Western markets at 39%. Here's the strategic difference. America's approach relies on perfect vehicle intelligence. China's approach builds smart roads that make autonomous driving easier. It's working. Waymo operates in 5 U.S. cities after 15 years of development. China scaled to 19 cities in 2 years. The system faces limitations in inclement weather and complex, unstructured scenarios where infrastructure support is unavailable, but the speed of deployment is undeniable. But established robotics technology claims number 4. The 4th position belongs to BYD, Advanced Electric Vehicle Technologies. BYD achieved 10 million new energy vehicle production milestone in 2024, becoming the first automaker globally to reach this target. The company's Yangwang U9 supercar accelerates from 0 to 62 miles per hour in 2.36 seconds with a top speed record of 308 miles per hour. The vehicle employs the DSU suspension system, enabling 3-inch vertical wheel travel with 40 millisecond response times, creating coordinated movements synchronized to audio input. The technical achievement here involves quad-motor independent control with torque vectoring enabling tank turns, 360-degree rotation without forward motion, and crab walk lateral movement for parking. BYD's 1 megawatt charging system delivers 249 miles of range from 5 minutes of charging, utilizing 1,000 kilowatt power delivery. With rapid scaling from battery manufacturer to integrated automotive producer, BYD achieved cost advantages, enabling the U9's $233,000 pricing compared to Ferrari's $500,000 plus equivalents. The company's vertical integration from battery cells through vehicle assembly provides manufacturing efficiency advantages. Western automakers can't replicate without restructuring entire supply chains. Engineering experts note that BYD's focus on electric powertrains enabled leapfrogging traditional automotive development timelines by avoiding internal combustion complexity. However, the brand faces perception challenges in Western luxury markets despite superior specifications. The company's battery technology benefits from Chinese supply chain dominance in lithium processing and cathode materials, providing cost structures difficult for competitors to match. While Tesla pioneered the electric vehicle revolution, BYD industrialized it at unprecedented scale. But Chinese transportation technology takes bronze. Taking the bronze. China's Maglev train development. China's Maglev trains reached 404 miles per hour during testing, with commercial systems accelerating to 404 miles per hour in 7 seconds. The technology uses superconducting magnets for contactless levitation, eliminating wheel friction. Operational deployment would reduce Beijing to Shanghai travel time from 5.5 hours to 2.5 hours. This achieves something unprecedented: ground transportation approaching commercial aircraft cruise speeds while avoiding airport security delays and weather restrictions. The system requires dedicated elevated guideways with electromagnetic propulsion coils along the entire route length. The acceleration capability addresses long-distance intercity transportation, competing directly with domestic aviation. However, Maglev infrastructure costs exceed conventional high-speed rail by factors of 3 to 5, limiting deployment to highest density corridors. Meanwhile, America's fastest Amtrak reaches 150 miles per hour on limited routes. The infrastructure investment gap between these nations is staggering, but America's robotics legend claims silver. The runner-up position, the Unitree H1 speed record robot. Unitree's H1 Humanoid achieved a Guinness World Record in March 2024, reaching running speeds of 7.38 miles per hour, faster than any bipedal robot ever demonstrated. Standing 5'11" and weighing 110 pounds, the H1 features 43 degrees of freedom enabling fluid, human-like movement. The robot demonstrated capabilities, including synchronized dance performances at China's Spring Festival Gala and dynamic balance recovery after physical impacts. The engineering achievement involves real-time motion planning algorithms processing sensor data at millisecond intervals, enabling the robot to adjust gait mid-stride. Unitree developed custom high-torque actuators, providing instantaneous response while maintaining energy efficiency for extended operation periods. What makes this significant is proving bipedal robots can match human athletic performance. Previous humanoid robots moved cautiously to maintain stability. The H1 runs at speeds approaching human jogging pace while maintaining balance on uneven terrain. This represents fundamental advancement in dynamic locomotion control. However, speed without practical application remains a demonstration of capability rather than deployed utility. The robot operates in structured environments with predetermined paths, and autonomous navigation in complex real-world scenarios remains limited. While China optimized for impressive performance metrics, the question remains whether speed translates to useful work, because number one reveals which approach actually wins. And claiming the number one spot, Boston Dynamics' Atlas humanoid robot. After examining delivery drones, agricultural automation, and speed records, this technology reveals who's actually winning the robotics race, with over a decade of proven research culminating in commercial deployment. Boston Dynamics retired its hydraulic Atlas in April 2024 and unveiled a fully electric version designed for real-world factory applications. The new Atlas moves beyond human anatomical constraints. Joints rotate freely in configurations no human could replicate, enabling machine-native agility for industrial tasks. In August 2025, Boston Dynamics and Toyota Research Institute demonstrated Atlas powered by large behavior models, performing continuous sequences of complex manipulation and locomotion tasks autonomously. Watch as the robot packs, sorts, and organizes objects using whole-body movements, self-adjusting when researchers introduce unexpected obstacles mid-task. Here's why this wins. Hyundai Motor Group announced plans to purchase tens of thousands of Atlas robots starting in 2025, marking the transition from research platform to commercial product. The company will deploy Atlas across its global manufacturing facilities, representing the first large-scale commercial humanoid robot deployment by a major corporation. This isn't about the cheapest robot or the fastest deployment. Atlas represents 2 decades of fundamental research in dynamic balance, real-time adaptation, and whole-body coordination. While China flooded markets with thousands of specialized robots optimized for specific tasks, Boston Dynamics solved the harder problem, creating a general-purpose humanoid that can handle unpredictable real-world environments. The robot's integration of NVIDIA Isaac GR00T4 AI-powered behavior planning, combined with custom electric actuators providing unprecedented strength and precision, creates capabilities no competitor currently matches. Atlas performs parkour, navigates obstacle courses, and manipulates objects with dexterity that require decades of iteration to achieve. Engineering assessments indicate Boston Dynamics' approach prioritizes capability over cost, betting that superior performance justifies premium pricing for industrial applications. Early customers include automotive manufacturers, logistics companies, and research institutions requiring reliable autonomous operation in complex environments. The technology demonstrates America's strategy: perfect the fundamental technology, then scale production once capabilities are proven. This represents the ultimate difference in philosophies. China industrialized existing robotics and deployed at unprecedented scale. America invested decades in foundational research to build robots that can truly think and adapt. The market will ultimately decide which approach prevails, but when the world's largest automaker commits to deploying tens of thousands of units, that's validation of the long-term strategy. So who's actually winning? China dominates deployment numbers and market penetration. America leads in breakthrough capabilities and foundational AI research. But the real answer is we're watching 2 completely different strategies play out in real time. And if you want to see which approach defines the next decade, subscribe and hit the bell, because this race is just beginning.